Hey everybody, this is a presentation about testing in CloudStack, so it sounds like you guys already heard a bunch of this from Pierre-Luc. Hopefully I'll be presenting some additional information that'll be useful. So who am I first? I'm Mike Tutkowski. I'm a software engineer at SolidFire in Boulder, Colorado in the US. I'm actually 100% of my time is spent on CloudStack development. Most of the time, I'm in the storage component of CloudStack, since SolidFire is a data storage company. But I do have to wander into the hypervisor area, especially the hypervisor area, to enable it to make use of our type of storage. In our case, we're really focused on quality of service guarantees. So the ability to be able to create back-end volumes that have a minimum guaranteed number of IOPS, and then you can set maximum and burst IOPS and things like that. But the idea is to be able to guarantee performance on a volume-by-volume basis in a shared infrastructure. So kind of like having the predictability, the performance predictability of dedicated hardware, but the shared economics of a large storage infrastructure. I don't think we have a whole lot of time for these, about 25 minutes, so I'll go through some of these pretty fast. This is just sort of background information about the company, just to kind of give you some idea what I'm using Marvin for when I do my tests. In our case, this is an all-flash array, which is used mainly to, I guess, achieve performance predictability at the lowest level, so we can build our quality of service system on top of that. So there's no spinning disks involved in this particular array for that reason. And we achieve a cost per gigabyte to be on par with traditional disk-based SANs by using compression, deduplication, thin provisioning, techniques like that, efficiency techniques. So it's actually a very cost-effective SAN as well. And then the part that I use a lot in CloudStack is the bottom line there, the REST-like API, similar to what CloudStack has. In this case, SolidFire has a REST-like API that allows us to automate all the different aspects of the SAN. So even our GUI sits on top of the same REST-like API. As a CloudStack engineer, I use the same REST-like API when I develop features for CloudStack that have to interact with our SAN. So that's really cool too. It's built from the ground up to allow automation at every step of the way. All right, so not sure how familiar everybody is with Marvin. So I'll just provide a little bit of information on what Marvin is. Marvin is a CloudStack testing framework. Part of the, I guess some of the points that are of most interest, at least to me personally, are kind of bulleted out here. One of the interesting parts that I use for Marvin is this deploy data center module. It's basically a Python module that takes in JSON formatted input, which describes the cloud that you'd like to build, and then deploy data center, that module goes off and builds it. Alternatively, if you were doing this manually, you would go in through the GUI, you'd go to the, I guess, the create zone wizard, and you'd walk through all the steps manually. Obviously, if I'm automating tests, I can't be using the GUI in such a way, so deploy data center is the module of choice in the Marvin framework that I use to build up my cloud. Also, Marvin provides low-level communications facilities, so signing your API requests and really low-level stuff like that when you're sending information to CloudStack, different commands and such. The next point is kind of related to that, but it's a little bit higher level. It's just pointing out that Marvin has a whole bunch of pre-built modules which allow you to easily create commands that can be sent to the CloudStack backend. So you could picture these commands sitting on top of that previous point, which is the low-level communication. So Marvin provides all of these facilities. You don't have to worry about things like that. And then another point of interest is Marvin, it actually provides a lot of general purpose functionality that's just useful to have when you're running tests. As an example here, I just say, being able to restart the management server. So I don't have to actually write that code. That might be something that's commonly done in these kind of tests. And we call that part of Marvin as well. It's just a module that contains some utility functions. And those are very helpful as well. So really Marvin is a collection of all of these different concepts. The bottom one is just talking about Marvin and how you actually can run tests using Marvin. And this is very similar if you've used unit test frameworks like JUnit or something like unit test for Python. You basically can write a Python module that has methods that are prefixed with the word test. And then if you run it with an application like nose tests, it will find your setup method, invoke that, run your test methods, anything that starts with a test prefix, and then eventually your teardown. So really Marvin is kind of a combination of all of these different things. So the word Marvin can mean different things depending on the context. I figured just point that out. The bottom line there is just where we kind of document in a little bit more detail on CloudStack's wiki what Marvin really is. But it's fairly easy to use. I know it was a little confusing to me at first when I heard of it, because some people were actually referring to things like the deploy data center module. Some people were referring to things that were run with nose tests and actually invoked your test methods automatically. And some people were referring to the low-level communications that it provides. And really, it's like all of these things. And this is just an example. So that top line just shows I'm running the application nose tests, and I'm passing in a Python module called test CloudStack server, which might look something like the bottom here, where you have a Python class, you've got a setup method, do all of your initial configuration. Then at the way bottom, I've got a method that starts with the word test. So nose tests would know to run that code. You could have multiple test methods. And then when you're all done, the teardown method gets invoked at the end. So it's very similar to a lot of unit test frameworks. And that's part of what Marvin provides. Good. All right, so in my particular case, I have three sort of steps here. I need to set up my test environment. I need to create a cloud that consumes that test environment. And then I need to run my test scenarios. And we'll walk through all of these right now. So what does my test environment look like? Right now, I have a single physical server in our lab back in Boulder, Colorado. It's running ESXi. And then on top of it, I have just 3 VMs right now. One of them is an Ubuntu VM, which is running the CloudStack management server, the CloudStack database. So the CloudStack database is not on a separate server in my case. It's actually on the same server. And then secondary storage, in my case, is also housed on this same VM. So it's a very simple configuration. I don't actually have the database and secondary storage on different servers. For the sake of testing simplicity, I've got them all bundled into the same virtual machine. And then I have 2 Zen server VMs. So what you can see here is I'm actually using nested virtualization. I have ESX running at the lowest level. And then on top of that, I have Ubuntu, and then Zen server, and then Zen server. And what's going to happen is we're going to take our Zen server hosts and give them to our CloudStack management server and create our cloud that way. Okay. All right, so then just looking at this kind of from a high level, not really looking at it whether this is done manually or in an automated fashion, what do I actually have to do every single time before I run my tests? The first thing I need to do is talk to that ESXi host and reset those virtual machines back to a previous snapshot. So once I set them up the very first time, I shut them down, I took a snapshot, then I started them back up and I used them for a while. Whenever I needed to restart my tests, the first thing I do is I go to the ESXi host, I reset these virtual machines, the Ubuntu VM and both Zen server host VMs, back to an initial state, and then I restart them. So I know they're now in a known good state. The next thing I do is I go over to Zen Center, and I take my Zen server hosts, which are just VMs, again, running on ESXi, and I put them in a resource pool. Zen server calls a resource pool is like a compute cluster. So now those guys are ready to be given over to CloudStack at this point. And that's the third step here is I basically go into my Ubuntu VM, issue some Git commands. So Git is a version control system that we use to interact with our CloudStack code base. So I'll go ahead and fetch the latest from whatever branch I'm testing. In this case, the example is the master branch, but it might be 4.4, 4.5, whatever I'm testing. I'll go ahead and rebuild the database. Actually, let's see here. Compile the code, rebuild the database, then run the CloudStack management server. So everything now is all ready to be, we're in a position where we're ready to create our cloud at this point. We've got our management server up and running. We've got our hosts in their own compute cluster, and they're ready to be handed over to the CloudStack management server. So this is just showing what it looks like manually, just to give people an idea. On the left there, I have a vSphere client running, and I don't know if you can actually see it. That's vSphere. That's actually my ESXi host, and these are 3 VMs. I think that top one is the Ubuntu VM, and then I have my 2 Zen server VMs below it. And you can see I'm actually on the Ubuntu VM. I'm in the console view. I'm just issuing commands to Git, like fetch the latest code base, compile the code, rebuild the database, and then run the CloudStack management server. And then on the right side, that's Zen Center, and it's taking in my 2 Zen server hosts, which are running in VMs, and it's how I combine them into a compute cluster for Zen server. So manually, this is how you would accomplish it. When we look at it in an automated sense, what I do is I actually have a Python module that runs, which uses another Python module called PySphere, and that is used to issue commands to ESXi to revert my 3 VMs to the known good snapshot state. So that can be done very easily in an automated fashion using PySphere, just the Python module. The next step here, instead of going into Zen Center manually, is using this XML RPC lib Python module to issue Zen API commands to my Zen server hosts to combine them into their own compute cluster. And then finally, I can use Paramiko, which is another Python module, to use SSH to get into my Ubuntu VM, and then I can issue my Git commands to update the code base, recompile the code, rebuild the database, and then run the CloudStack management server. All right, so now that we've got kind of our infrastructure already, we need to actually turn to the process of creating a cloud. What I want to do in the end, I just want a single basic zone, 1 pod, 1 cluster. I want to take my 2 Zen server hosts. They're ultimately going to have local storage on each of the Zen server hosts. So I'll start off with 2 primary storages, just local primary storage. And then my secondary storage is just that NFS share that's on my Ubuntu VM. Ultimately, this is where we want to get to. The first thing here is just kind of demonstrating maybe what we've all seen before, the process, it's just really 2 screenshots here, but the process of normally walking through the zone creation wizard. You'd obviously have to provide all of this input manually. And this is something that for a long time I had to do all these tests manually. This was just part of my process. Very tedious to go through and redo this every single time. Obviously, I replaced it now with a JSON configuration file, which describes the cloud that I ultimately want the deploy data center module to create for me. So just a reminder again, deploy data center is just a part of the Marvin code base, and this takes in JSON input that describes your cloud. For example, providing like IP addresses for my Zen server hosts, and the IP addresses that CloudStack can use when it spins up VMs. All sorts of stuff that you would provide through the GUI. This is described in this JSON configuration file, and I just run it through deploy data center, and this builds my cloud infrastructure with the Zen server hosts and the Ubuntu VM. All right, so then now that I have this cloud up and running, I need to run a lot of tests on it. I have probably hundreds of tests. And we just kind of go through the same process each time. This is sort of where your nose tests comes into play, where you're running different Python modules that have setup sections, they have test methods, and then they have a teardown method. So what you might see here is create some resources. For example, maybe I need to add primary storage to the cloud that's based on SolidFire storage. So we already had local storage. Now I want to actually execute a command to create primary storage that's based on SolidFire storage. So something like that might happen in my setup method, as well as creating disk offerings or compute offerings, anything that I really need to test. So for example, I might be testing, setting a minimum and a maximum number of IOPS for a disk offering, and then later going and executing that disk offering to create a volume that I attach to a VM. So that's kind of the create resources part here. The running of the test scenarios, that's where you see these test methods come into play, where nose tests runs this method that starts with test, then it runs that method that starts with tests, and then you basically get into the situation where you're actually using those resources that you created in step one. The third step, which is kind of interesting, is verifying the CloudStack database. So normally, when I run these tests manually, if I go and create a manual disk offering, and then I go and manually create a volume based on that disk offering, and then I attach it to a VM manually, at some point I actually need to go into the CloudStack database and verify that certain fields, like the minimum IOPS, the maximum IOPS, that they're actually set the way that I expected them to be set. So what I do here in step 3 is I've actually written a plugin, an API plugin. So CloudStack's API is extensible. And what I've done here is I've written an API plugin which just has a bunch of methods that are really useful in my particular case. Let's say I know that I created a volume that I've attached to a VM. Now I want to go into the database and actually verify the IOPS. Well, some of these things you can actually get through CloudStack's standard API. Some pieces of information are stored in tables, like the cluster details table or the storage pool details table, and there's really just no CloudStack API call you can use to get that information. So what we did here was build an API plugin that just allows me to provide my own very specific functionality, so I can draw the information that I want out of the database, and then I can compare it against what I expect to be in the database. And then the fourth one, which is really not so much CloudStack related, but rather SolidFire, is I'll go off and use that SolidFire REST API to talk to the SolidFire SAN and say, all right, so CloudStack, I was supposed to make a volume with 1,000 minimum IOPS. The CloudStack database says I've got 1,000 minimum IOPS. What does the SolidFire side say? And so I can kind of verify that everybody's on the same page. So pretty much just kind of do that over and over again, depending on what my particular test is. I guess set it up, run the tests, tear things down, and just kind of repeat for the next test. Yeah, so this is just the manual process, just to kind of illustrate how tedious this was beforehand. So when I first started in on CloudStack a couple years ago, my initial push was to get quality of service implemented, at least at a basic level, be able to provide the functionality for users to set minimum IOPS, maximum IOPS, and so on. And I didn't really have time to automate the testing, so I just kept on building out manual tests. And of course, as I added more and more features, it became more and more time consuming to manually verify things. It could take a week or more to go through all these tests manually. So, but in the past, this is what I had to do. I had to actually create my cloud manually, go in, create primary storage manually, disk offerings, compute offerings, look in the database myself, look on the SolidFire SAN myself, just make sure everything was squared away properly. Very time consuming. So that's what this is describing here. Obviously, we want to automate that. That's not a scalable process, especially as I continue to add additional features. So how did I do it in an automated sense? The create resources part, as we described, that was all done through Marvin in terms of the setup section of the test. So create resources like primary storage and compute offerings and disk offerings running the test scenarios, these are the test methods. So I might actually take a disk offering that I created, and in one of my test methods, I might actually execute that to create a real volume, and then execute an API command against CloudStack to attach that to a virtual machine. So a lot of that activity is happening in these test methods. And then the verification of the CloudStack database, as I mentioned, that's done through, the Marvin test methods invoking my custom API framework to draw particular pieces of information out of the database. So I can actually see, well, I said I was supposed to, create a volume with 2,000 IOPS. That's what I passed into CloudStack. Now let me call my API plugin and draw that information specifically out of the database and see if the database agrees. And if that's successful, let's do step 4, which is talk to the SolidFire SAN and see if the SolidFire SAN agrees as well that that's what we have in terms of IOPS or whatever particular metric we're looking at. All right, cool. So, and then ultimately I have, so now that I've automated a lot of this, it's not completely done. So for example, like I mentioned, I have tons and tons of manual tests. I've automated a small fraction of that. I obviously plan on continuing to automate, but ultimately too, I'd like to run this in more of like a Jenkins environment. Right now, what I do is when the time comes to actually run these tests, I just manually kick them off, and they run for 10 minutes or something like that. And then if everything comes back successful, I'm happy. It saved me a week worth of work. That was great. But I still have to do those other tests manually. So part of what I'd like to do is integrate this with Jenkins, maybe have a master-slave relationship with a CloudStack master, and whenever code gets checked in, have my slave be notified. I can build that code and run my tests. Still, until everything that I have manually written up is implemented in an automated fashion, I still have some manual work to do. I'd also like to add support. My manual tests include support for KVM and VMware. Right now, I haven't really done any of that in an automated sense, so that's one of the things that's on my list to do as well. So there's going to be other Python modules that I have to dig up on the internet or find out how do you communicate with, I don't know. Well, I guess KVM, I'd probably just use SSH and issue commands that way. And VMware, actually, since my host that everything runs on is ESX, I could use the same library to send commands to nested ESX hosts. I just haven't had a chance to do any of that yet. And then the third part is I'd actually like to combine it with a SolidFire testing component. We call it AT2. It does a lot of things, but one of the most important things it does for my purposes is it has an API which allows you to actually send commands to build out SolidFire clusters. So I could say, before I run any of my tests, I could say, AT2, can you build me out a 5-node cluster with SF3010s or SF6010s or whatever model I want to run, or maybe it can be something as simple as I just need a 1-node cluster for testing purposes. But this way, my SolidFire SAN is completely built from scratch with however many nodes I want, whatever model of hardware I want, and whatever version of software I want. And I don't actually have to do any manual imaging operations. So there's quite a bit of work ahead of us, but it's been good progress and saved me a lot of time so far. And it's just a matter now for me to kind of mix it in with my regular development activities and kind of find a balance there. So did anybody have any questions?